you and I and everyone else, we read all the AI news, see what's going on. I think we can all agree that code generation, automating what programmers are doing, even getting into like product design, and there's maybe not enough like platform engineering AI stuff I hear about as I'd like to, but it works. I think, to put it one way. And I think what you have had firsthand experience with, as well as the other people on your team, is given all of that, if you are producing software, how do you decide that you can actually ship the software, that you trust what was created? You feel the pressure to like ship more frequently, which we've already been doing as much as possible. And now you've got to make the leap to like, well, I'm the one responsible for this. Ship it. Like, how are you getting comfortable with making that call and doing it in a responsible way?
Excellent question. Let us put it clearly on the table. There is no denying that AI is accelerating everything, especially for us as an ISV. It is definitely accelerating the rate at which we are able to produce code, produce releases. Now, the math is not as simple as you might think. Just because AI accelerates code generation doesn't mean I can release software at the same speed, because building enterprise class software is a lot more than code generation. Code generation often just accounts about 20 to 30% of the time. Rest of the time is spent in planning. It is spent in testing. It is spent in validation. It's spent in packaging the releases, getting information out to the customers. And so what we do find is our ability to release faster is definitely there. And when I think about releases from a business perspective, now remember, we are not a SaaS solution. We are a software solution, right? So anytime we release software, customers have to pick up that software and deploy it to their environments. So what we found was there are two parts of the release cycle. One is definitely with AI-assisted security management and vulnerability analysis. We are finding a lot more vulnerabilities. These vulnerabilities are not just high, what you traditionally call high or critical, but these are also vulnerabilities that might be considered low, that are chained together to create an exploit. And in those scenarios, the speed at which we are detecting vulnerabilities, finding fixes, and issuing patches is exponentially higher. We do that right away, and we want to get the fixes out to the hands of our customers. So what you would think, as you know, we are part of the Spring open source community. And we have gotten more identified vulnerabilities in the last few months than we got in the last few years. And that is because with AI assistance, you can find more. But it's not just that it is good for the bad guys, it's also good for the good guys. It allows us to find it faster, fix it faster, and get it out to the customers faster. So there, the release cycle has sped up. But on releasing features and functions to customers, there's still a constant debate. How soon do you want? We do want to be much faster than we were before. But at the same time, it has created a higher requirement on making sure that these releases can be adopted also, that they can be upgraded fast, that customers can get the features fast. And that is the balance that we are playing with.
I think most people struggle just to keep up with security and patches, let alone whole new feature bases. So there must be a lot of thinking that goes into, be careful what you ask for, as far as like a pile of whole new features that we're going to unleash upon everyone.
For sure. And what we have to do is think holistically. If we can release faster, we will release it faster. But it is not just about the software. We have to think about that whole life cycle that a customer has to go through. And we have to say, how can we impact that? How can we shorten that? How can we make it easier for them to adopt so that they get the benefit of the innovation, right? So it's our responsibility not to just throw out new releases, even if they're enterprise class and well tested, but also make sure that they can be adopted.
What about the other phases of the software development lifecycle, like from the programming parts or from design or from doing the kind of product management, the product planning? Like, what's been the experience we've had applying AI to those parts?
As an ISV and as a leading ISV from a VMware perspective and Broadcom perspective, we have embraced AI fully, right? And this did not come in phases, or it was not a gradual thing. At one point, we were worried about AI and what negative impacts it could have. But then next, it was a step function, and we said, my goodness, we cannot afford not to, and this was a year and a half ago, not to lean in, because it's a question of competitive advantage. It's a question of security. It's a question of value to our customers, right? And so we leaned in very, very strong. And so as an ISV, my primary business process is software development lifecycle. And we have applied AI to that core business of software development, right? Not just coding, but the entire development lifecycle. But then we are in this unique position that not only do we build software, but we build software that helps customers run AI and build and run AI applications and build and run agents. So we are in this unique position where we are building software and accelerating our software development cycle using AI. We are also, at the same time, incorporating AI into our products to make the customer experience better. And we are taking all those learnings and putting it into our platform so that customers then can build their agentic software, can automate their business processes much faster on top of the platform that we deliver. So it's a very unique scenario where we get to see, but we also get to package it and incorporate it as an output to the customers. Now, specifically on software development lifecycle, as I told earlier, coding is only 20 to 30% of the software development lifecycle. We look at that entire lifecycle, and we have done some very interesting things around planning. How do you do requirements management? How do you do prototyping? How do you do UI UX development? We have done a lot of interesting things around how do you do testing? How do you have automated swarms? And how do you do things like security? How do you do things like analysis? How do you do things like validation, documentation? So we have looked at the entire software development lifecycle as a business process. And I would say we found a lot of interesting insights as we went through that process.
I want to hear what some of those discoveries are, but I was also curious, as you were going over this, about a year and a half ago, there was some trepidation and then kind of this acceleration to adopting it. And I wonder, where were you on that?
Well, of course, I run a business unit within Broadcom, which is the broad organization. And as I make my individual business unit decisions, but we also make Broadcom level decisions. And personally, I would say I've been I've seen having been in the tech industry, I would say my instinct was we should adopt it. We should adopt it fast and we should adopt it soon. And the good thing with Broadcom, while it's a very large company, it's very agile. Decision-making from the leadership down happens very fast. And so once Broadcom also as a whole recognized it, putting in the right structure in place, the right processes in place was very quick. We cut through red tape and bureaucracy and put all the right structure in place so that we could move fast.
So we decide that we want to move on this, and then we go through it. And like you're saying, we have lots of like a year and a half of experience and things that we've learned through it. Like what are some of the things we've learned? Because I think this is interesting because, as you were indicating, usually there's the joke of like we drink our own champagne that we sell, but in this case, we actually do.
I'll talk about some of the learnings in applying AI for my software development lifecycle, but it generally applies to everything. So when you look at a business process, there might be some aspects of the business process, and in my case, coding, that can be accelerated. But you have to look at the full business process to get true velocity. And in our case, we had to look at the software development lifecycle all the way from requirements management to validation to UI UX planning to coding to convergence of coding properly to merging to do enterprise class testing. All of that we had to look at it. The second one is AI is only as good as the problem and context you hand it. And initially we had very interesting experience. We gave AI tools to both senior and junior developers. And we found that there is no shortcut to thinking about what problem you are asking AI. Of course, you can help AI to refine it, but there's no shortcut to that. And being able to carve out that problem in clean, organized chunks is very critical. And we found that if you give a very amorphous problem, you get amorphous answers. And especially in coding, you get big blobs of code that become undecipherable, hard to debug. So AI is only as good as the problem you hand it. The second thing we found is that, look, AI is very creative. You can offer it problems, but it treats every problem, it treats the same problem in every run as a new problem. So
Right,
you can
right.
give the same prompt, and if you run your tools, your models against it, or your coding assistants against it, you will get as many answers as the number of runs. And that is problematic because it creates inconsistencies, right? So you get code that is, first of all, very duplicative across developers, right? Common routines are duplicated. It creates this huge expansion of code base and makes it very hard to manage. So what we had to really think about is, where do we use AI's creativity versus where do we force more determinism, right?
Yeah.
Do I want my UX to look different based on which developer did which prompts? How do I build consistency in those building blocks? How do I create determinism in some standard modules, right? And this is where things like what we do with Spring Framework became very interesting. Do I want the method to log something, the method to do some standard checkpoint restart? Do I want that to be reinvented every time AI writes new code? Or do I want it some consistent patterns, right? That is a big area. And I'll tell you some learning, some things that we implemented to balance that. The third thing we found is that, look, AI just writes perfect code. It compiles. It looks beautiful. And often this beautiful syntax can hide structural and functional failures, right? You think a developer, even sometimes senior developers, get tricked into thinking that the code, because it's so beautifully formatted and documented, that the code that AI has written is good code. And so you have to really figure out how to break. It's a mindset thing that you have to, how do you break that pattern? And by the way, this is not just true for our industry. I heard this very interesting story where doctors often misdiagnose or do not diagnose issues with people who come across well-groomed. If someone looks
Right.
well-groomed, they say, oh, maybe you are okay, you're healthy. And it's not a analytical thing that they're doing, it's just more a psychological thing. And same thing happens with AI.
I would imagine there's even maybe a combination of things that could kind of, let's say, be a problem there. One, you were talking about every time you ask it probably will give you something at least slightly different. And then I would also imagine if you use a different model or just upgrade the model, that's a whole other thing, right? Like a whole other kind of introduction. And then combining it with the point you were just making, if it's doing something different and it's not to the intention that you originally had, it's going to be very convincing that it's what you want, right? It'll look very nice and well polished and explain to you why this is a better idea. So there's almost, it's, to anthropomorphize it, it's pretty good at unintentionally tricking you into, I've got a better idea. You should do things this way if you don't have control over it.
Yeah. Or, just straight up mistakes that you don't
Just gloss over.
Yeah, gloss
Yeah,
over.
yeah. And so I mean, I think that's a pretty significant list of things to contend with. Especially if, like you're saying, you're building enterprise software, right? That other people, that's at the foundation of what they're doing. Like, how have we been getting around that? Like, what have we learned to not have the smarty pants convince us that what it wants to do is
Look,
great?
I wouldn't say we have got around everything, but we have definitely evolved our approach to building software, which is our business, right? Process. And I would say one of the big things is we have to drive. One of the big things which I didn't mention earlier is you have to really get your entire team on board. And you have to do some organizational changes. So we reconfigured some of our development teams into a pod-like model where we had the software developers paired with the product managers, the UX experience, the architects, the end-to-end testers all together in a small pod, and gave them more responsibility with the AI, but also gave them more accountability so that they could discuss things faster, resolve things faster, and move much faster. And so getting that AI literacy going was very critical, but also transforming the organization was an important piece, and driving accountability across that life cycle. The second thing that we did is that we said, look, the AI will cause mistakes. We need to institutionalize the role of a challenger. We need still to have the human in the loop that is doing validation of issues and being able to look at the problems we are giving AI to code, for example, and say which ones are riskier, which ones are not. When should I go deep dive into the code? And what we found is you can get into fatigue, right? This is just like they talk about nasal fatigue. It's the same thing. You can get into a fatigue on the skeptic role. So you have to keep changing that skeptic role so that the brain stays fresh and you're looking at what is being produced with the context.
Oh, that's really interesting. So you move the challenger, as you say, to different people in the team, because people will they'll get worn out at challenging all the time.
They'll get worn out, or they'll get too accustomed to the perfectly formatted code that is coming out, right?
Yeah. You have to swap people out so they don't kind of. I guess there's kind of like being in flow is a positive thing, but you can also just be in flow of not quite seeing the details if they're poor. So you need to bust out of that.
Then the other thing that we did, so we reorganized, we created the skeptic role, and then the big problem was how do we do the balance between creativity and determinism? And there we absolutely are drinking our own champagne or eating our own dog food. We found that development frameworks are amazing at that. So we use a lot of Java. So we are using Spring Framework to guide us and guide our developers and guide the coding assistant into standardized patterns that are repeatable, patterns that we can go and look back at. So that we are doing that. And that gives a lot more consistency across these various pods, even when we merge the code. It allows us to create more maintainable code with more clearer outcomes. So we definitely have adopted more frameworks. We also have taken things that we do in a repeated way. I was telling you about the UX example. You want to code and with skills, you can do this very well. You want to code the experiences that you want to have in order to be consistent. You want to code all those guardrails as UX skills. So we created UX skills, but we also created fundamental building blocks that we might want to use in our user experience, right? And made them available so that the coding, when it happens, It is not trying to create new building blocks every time, but is able to reuse the set of patterns, and you get more consistent experiences across all these teams. And the same thing applies, by the way, not just to UX, but also other components within the software stack. Now we accelerate every aspect of software development lifecycle. We are using AI in every aspect of software development lifecycle. From the time you define requirements, we use AI to convert those requirements into stories, into Jiras. We use AI to help us prototype so that PMs can take it and show real things to customers, right? And get their feedback much faster. What would take weeks to get feedback, that is shrunk. We didn't start there. We started with coding, but then we have now got about 15 to 20 agents that are running, that are automating different parts of the lifecycle. We have automated how we build UX rapidly using this combination of deterministic model, but also AI. We have accelerated how we do planning and task assignment using AI, so that when any requirement comes in, the assignment of that task to the right pod, to the right developers is done. And by the way, we have automated, of course, the coding process, and we have automated the coding process with swarms. So you allow the same prompt to be sent to multiple agents, and you get back the results and you compare the results and find the best one. We have automated the whole testing process with test harnesses, unit test creation, testing QA swarms that give us end-to-end testing results. We have automated the complete documentation process so that documentation is automatically generated. We have automated the security and vulnerability analysis process using AI, and it has been delivering good results for us, very good results. And finally, even the whole packaging process and validating against how the upgrade would work, how would the customer take the adoption. So if you think about software development as a full business process, we are using AI across that entire business process.
You mentioned something there that seems interesting to explore a little bit, which is you can, when you apply AI across all these things, you can speed up all the phases. And one of them is, I don't know how to describe it, but showing prototypes to customers very early on and more rapidly. And I imagine you also get shown more prototypes, right?
Yes.
Like it's lots and lots of these things. So you experience this as well. And I wonder, as a consumer of that, and then also kind of seeing how customers react to it, like how should someone deal with that, right? Like, because kind of in the same way that the code generation can make the perfect code, you can kind of see the perfect prototype. So I imagine there's a little bit more discerning that you have to put into it, or just some more thinking than just seeing like, oh, I see it, it must be great, right? Like there's kind of some more analysis you might need to poke at it.
It's an interesting one, and I don't feel, at least now, right now, we are tripping on that much, because when you see a prototype, it's less about how it was built. It's a prototype. And it's not enterprise software. You know that. What you focus on is the outcome. And it allows you to visualize the outcome and very quickly validate whether the team is in the right direction or not. Is that outcome
right.
what we really want to deliver? So
it's kind of a feel you're trying to get. Does this feel like the right thing?
Yeah. And so the results have been pretty phenomenal for us on the software development lifecycle. We have reduced the time from a prototyping perspective from what used to take weeks down to just 1 week or so, few weeks. We managerial efficiency, all this boring work of task coordination, team assignment, Jira assignments, we have cut that time down by over 30 to 40%. Faster coding, given, millions of lines of code. We have done 100% AI generated documentation. We have done an amazing job in finding issues and vulnerabilities early, before it goes out to the world, and before an attacker might find it. with AI, we are able to actually now do a much better job of sifting through the noise that a scanning tool might do and produce and actually get to the most important pieces very fast and put the fixes in releases. We have reduced our mean time to respond when there's a support ticket, being able to analyze that ticket, being able to find the bugs. We have reduced it by 60%, the MTTR. So the benefits to software development lifecycle are huge, and I don't think we have seen the end of it. There'll be even more to come. But I must say, we are leveraging our own platform to solve many of these issues. We are using our Spring frameworks to guide the platform. We are using our own platform to run remote coding assistance, but also to run the MCP tools for Slack and Jira in a secure way. We are running all our agents on the platform so that these agents are secure. These agents have a clean runtime. We are automatically creating test environments with all the paraphernalia, the data sets, the databases, everything needed to test the software. And we are doing it in an automated, constructed way. We are giving these agents access to the underlying platform so that they can be configured correctly for this entire life cycle.
Yeah, what as I do my tiny experiments here and there, like I think the way what you're saying there at the end, the way the Tanzu platform thinks, as far as you tell it what your intents are instead of how to do something, like it aligns very well with like how to get an AI to behave, right? And so when the idea of I want to run this application in this platform, as you were kind of alluding to, bound to this database, rather than worrying about all the configuration of how to do it. Like you just kind of, in the same way that a human might tell an AI what to do or what they desire, you sort of like can tell the platform what it desires. And so it seems like it almost feels like if you were trying to make a platform that worked with an AI and kind of like AI code generation and even AI operations, you would have to do some glue work for it. But in this case, I think it kind of just works because it's always been an intent-based system.
Well, so maybe, Kote, we should again introduce, I don't know how much your audience know this, but we talked about we are in the business of building software. So maybe it's worthwhile to explain what is the software.
The software we've built.
Because they may not even know what we build, right? So what we build in this Tanzu business unit, at the core of it is a application development platform that many customers use to, it's actually an application platform, not just development platform, application platform that customers use to build their applications, but also run them at scale, manage them at scale securely across their environments. So it's an infrastructure platform that sits on top of your public or private IaaS API or container API. And it gives you this curated environment where it takes right from the time you write the code, it takes that code, it packages it into a secure container. It takes your intent, like whether you want HA, do you want encryption turned on, which regions you want to be deployed in, and takes all of that and automates that deployment across all those environments while maintaining your intent. And it does that automatically. So once the intent is defined, the platform automatically goes and configures the underlying IaaS infrastructure, compute, network, and storage, so that it meets the criteria. So from a user perspective, the API surface the CLI surface becomes very small. Instead of having the API for the entire infrastructure, how do I configure my compute? How do I configure my network, storage, my services? Which could be very large, your API surface shrinks down to just, hey, take this code, put it in production for me in an HA characteristics across region 1 and region 2. And then the platform takes care of all of it. And I'd say the biggest value we are seeing, especially when we use agents to also drive the platform itself, is that it reduces the surface area where things can go wrong. When an agent is trying to drive the platform, if it goes directly to the Kubernetes or the infrastructure surface, there is n variables it can configure and factorial n ways in which it can configure, which can cause a lot more exposure. Versus when you use agents to drive something like a platform, I'm talking about app platform, you get a very consistent small set of APIs that can be driven by the agent to get the objectives that you want. So that is what we build at the core, which is Tanzu Platform. And it comes with not only the ability to run these applications at scale, it also comes with an enterprise framework to easily build code, whether it is Spring or Python or Go or .NET. So truly accelerates the life cycle of from code development all the way to getting it out to production.
I think part of that, and this is what an application platform, the Tanzu platform, is always taken care of. You know, you're kind of alluding to applying the policies you have, having consistency in that and security, and that kind of, let's say, smaller surface of possibilities that the command line is. What's interesting there is, as we know with agents, they're very curious and they want to please you. And if you give them a very permeable sandbox, they're pretty good at breaking out of it to satisfy you. And it seems like that's the other benefit of the platform that we have, is you don't just have kind of like a sandbox. It's like an iron box that contains everything for you.
Yeah, I think so. I talked to you a lot about the learnings that we had. And you know what the Tanzu platform, app platform, which is a PaaS, platform as a service, does. So recently we released our agentic. We added an agentic foundation to our platform. And one of the big things that we spent a lot of time when we released the agentic foundation, by the way, it's just part of the platform. We believe agents are just next generation of apps. And so your traditional apps, your microservices apps, and your agents all should be running in the platform, not separately in a silo. So that's the first thing. The second thing is, to the security point, we said, okay, if we are running agents that have agency to do something, we have to be very precise about what we ask the agents. But we also have to be very careful about where we run them. How do we sandbox them? How do we make sure that they stay secure? And so we invested a lot in what we call a secure agent runtime. The secure agent runtime gives you a sandbox that not only sandboxes the resources, but also the networking connection, so that everything when in that sandbox is denied by default. The agent has access to nothing. And only when you as a user say, hey, this agent needs access to certain MCPs, certain memory, certain databases, a specific bind is done so that the agent has access only to those specific services. We also make sure that any secrets that need to be there to communicate between the agent and other services are maintained by the platform and never given directly to the agent. So it can't use those secrets to maybe optimize some other goal, right? We make sure that clean auditing and logging is baked into this runtime for everything that the agent does. And so this agent runtime, hardened agent runtime, is kind of the core of what we have done with agent foundations. And I'll tell you an interesting anecdote. So Alibaba had this agent called Roam, and it was given an objective to optimize their net infrastructure. Now the agent is, of course, very smart. It said, hey, I've got network connectivity. I can punch out, and I can set up a Bitcoin mining setup on my infrastructure to make use of all the unused capacity and earn some dollars. So it was optimizing for the goal, which is
Right.
spend the least amount of dollars or earn the most amount of dollars. But it was an unintended consequence. And so since you do not know what an agent can and cannot do or will imagine up, defining that boundary and having a deny by default model to say, agent, you're just doing this and nothing else, right? And even if you come up with something, you don't have the way to punch out to the network and set up a Bitcoin mining setup, for example. So the notion that this agentic runtime is very secure and it's denied by default is the critical component of this new agent foundation, right? That's what you said about security.
Yeah, and I think our colleague Adib, he has this phrase I like a lot called prompt begging, where you're begging the AI to do something for you. And I think what you're going over. You don't want to just beg the AI to be responsible. You want to almost do something outside of it, not almost. You want to do something completely outside of its control to just make it not possible to do it, right? Just like, even though in this container it's running in, it might have full access to the image and all of the commands it could run in a shell. It did all of that, the capabilities that you want. It can't go out onto the network. And so having that box that you put it in, I think it's very important.
Yeah, it can't go out of the network. It cannot use more resources than it's given, so it can't get into an endless loop, right? It doesn't have access to the credentials. Everything gets logged. So look, this is something that we'll have to keep evolving, but at the heart of what we have put out with this agent foundation is this agent runtime. But that, as I said, is insufficient. From another learning was you need to have strong frameworks. So we are including, as part of our agent foundations or the platform, number one, an out-of-the-box agent. It's a Python agent, but also agent build packs, that when you build agents, you're able to build them securely without any prompt injection happening during that supply chain process itself. So, and then we also include Spring AI, especially, which is for Java developers, gives you a great way to start building your enterprise agents, right? So give you an agent runtime. We give you all the builds and the agentic software you need to build your agents. Then we equip the platform with all the components you need to do brokering, such as being able to broker out to models, broker out to services, broker out to MCP gateways, being able to control that access, being able to do tool level control. That's all baked into the platform. And so when you have these things, then going from an agent to asking the agent to do something might be as small as just writing a small agent.md file, defining some skills, and doing a CF push. Automatically, the agent is up and running. It gets access to MCP tools that it's authorized to. It gets access to models. It gets access to stores, but only everything that is authorized. So the notion of building agents and putting them to use, a lot of the friction around how do I set those up, how do I get them running at scale, goes away, allowing our customers to focus on what is the business process that you're automating. So in our own case, we are using our own platform, and we run and scale all our agents on the platform. So it gives a very fast way for our development team to move. We also included within the platform, of course, data pipelines. And remember, data is a very critical piece of the puzzle here, because that's what gives agents the context. And so making that data pipeline integrated into the platform, whether it is event-driven document ingestion, being able to then convert it into vectorization, being able to store into vector stores, being able to offer that as a cached solution to agents, all of those capabilities are also baked into the platform. So once you have Tanzu Platform with these agent foundations, our hope is you can accelerate your agentic development to automate your business process, whether it's banking, insurance, doesn't matter, much faster but also more enterprise grade and secure.
So to identify a small thing you were saying there, right? Like when you look at the agent build pack, it actually ships with like a little chat application built into it. So like right away, you can start to do something. And like you're saying, with all of the data services in the platform, you can bind to those data services, and you can start to get to what you want to do with AI instead of worrying about all of the plumbing and all of the securing behind it.
And let's just put timeline, right? So because this is a foundation, as long as you've got an IaaS dial tone, whether it's, of course, we work very well with VCF, but it can also be public cloud. That foundation can be installed in a matter of few hours. From there on, you have a secure environment, and you can open it up to your teams. And the teams can have a working agent in a matter of minutes, right? So it allows for safe experimentation. It unleashes the power of agents to your organization, but allows you to control what it can access so that you don't have inadvertent damage being caused.
So we just came out with, I guess it was in April, the 10.4, everything we've been talking about. And do you get the sense that our release cycle might be a little faster now using all of that? Like what as we look towards the next release and the one after that, do you think there's just going to be tons of new features in that as things evolve, or how are you kind of managing the cadence of all of that? What's your prediction now for what it'll look like?
There are two ways. Either you can release fast, or you can keep the release cadence same, which is about quarterly to 6 months. Keep the release cadence same, but increase the payload, right? The payload that is coming.
Right.
And
but more in it.
More in it. So as I said early on in the conversation, we are definitely accelerating our patch releases, right? We are able to find issues fast. We find it, we fix it, we patch it, and we get it out to you. On our overall release cadence, right now we are maintaining our release cadence as is, but I expect to be able to double the capability, the innovation, and the feature payload on these releases in terms of solving problems for my customers. So it kind of is a good balance between not going so fast that we don't give the customers time to adopt and deploy. So helping them deploy, helping them upgrade faster, but also giving them more capabilities every time they upgrade.
Well, that's good. It seems like pretty soon then we'll have a reason to talk again.
Yes.
as we have a different cadence, as you will. Well, great. Well, this is really interesting, especially, I mean, as we started off with, right? Like, I think the perspective I don't come across very much is how do I manage all of this, right? And how do we address the organization thing? Like, one thing that I thought was really interesting is the as we call them, pods. But like, if we need more human thinking and intervention with this new team member, then we might as well like bring them closer together to kind of speed that up as well, instead of having this communication gap. But there's all sorts of interesting stuff we covered. Is there anything we missed that you want to make sure to get out?
I think we covered everything, Kote. I just can leave this with which is, while every time there is something new from AI, there is fear and trepidation, there is equal amount of reasons to be positive. You know, this whole thing about AI being able to hack and find vulnerabilities has caused a lot of kerfuffle here. But I would say it also helps us prevent bad actors, right? And so it helps us get to innovation faster. It helps us be more productive faster, right? With what the time we use, and gives us more leisure time then, right? So to me, I feel like I see this as a glass half full rather than half empty.
Yeah, absolutely. I agree. Well, speaking of more leisure time, we should wrap up and maybe get to some leisure. All right. Well, thanks again. It's fun as always talking.
Thank you, Kote.